Okay, so we're in chapter 3.1 now. Just getting back to where we left off. So we're talking about measures of central tendency, which is kind of fancy words for mean, median, mode. And so far we've only looked at one example of that. This is the example that I went through in the last video there. So in problem 2, it says the following data represent the birth weights, which are in pounds, of 17 randomly sampled babies. Okay, they want us to compute the sample mean, median, and mode. Okay, so because we have a sample mean, x bar is the symbol, not mu, but x bar. Okay, now the mean is the mean, regardless of whether it comes from a population or a sample. It's just getting the symbol correct. So all I'm going to do here is I'm going to add up the 17 numbers, and I get 128.6, and then I divide by 17. 128.6 divided by 17 is approximately 7.56 pounds, if I round to the nearest 2 digits. And by the way, something that I've noticed here, just as far as rounding, so in this chapter and pretty much forward, if you're given a data set that, let's say the data values go to 1 digit, okay, when you compute the mean or the standard deviation, which we'll get there in the next section, but usually they'll have you go to the nearest 2 digits. Okay, if you have whole number values like we did in problem 1, they'll want the mean to go to the nearest 1 digit. Okay, so it's like you'll go a digit past the data values, whatever they are. Okay, so I found the mean, 7.56 pounds. That's the average. And now we find the median. Okay, I need to order the data set from smallest to largest. Okay, so I did that. There's 5.8 is the smallest number. 6.3 is the next smallest. Then 6.8, I've got 2 of them. And then I go all the way up to 9.2, which is the biggest number. Now I've got 17 weights listed. And because 17 is an odd number, I just pick off the middle value. Okay, the middle value is would be the 9th number that's listed. Okay, so the 9th number, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 7.4. Okay, and the 9th number is going to split the top 8 from the bottom 8. Okay, so the median would be 7.4 pounds. The mode, so I'm looking for the value that I see more often than any others. And looks like there's 2 modes here. So 6.8 and 7.3. I see 2 of those. There was only 1 of every other number there. So this would be an example of bimodal data set. I just write mode equals and then the 2, that I see, 6.8 and then 7.3 pounds. Okay. How many babies in the sample have birth weights that are less than the average? Okay, so here's the average, 7.56. So how many babies listed have weights that are less than 7.56 pounds? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9 babies have weights that are less than 7.56 pounds. Okay, so one thing that I'd like you guys to notice here is that the average is not always going to be the middle value. Okay, in a bell-shaped distribution, it's very near the middle. Okay, if it's not exactly in the middle, but like if it's skewed one way or the other, the mean is not going to be in the middle. Okay, and we'll definitely see some examples of that. So I mentioned that 8 babies have weight that's less than 7.4 pounds, and 8 babies have weights that are more than 7.4 pounds. Okay, so and here's 9 babies that have weights that are less than the average. Okay, so it's kind of somewhat skewed, not really. Okay, but you're getting 9 babies instead of 8 babies. Okay. Problem 3, the number of homicides reported each month in Chicago in 2017 is shown below. Okay, so there's our data values. Okay, so there's 55 homicides in January, 51 in February, 40 in March, etc. They want us to compute the population mean, median, and mode. Okay, so the population mean is mu, and again, I need to add up all the numbers and then divide by the total. So when I add up these 12 numbers, I get 662 as the total. Divided by 12, 662 divided by 12 is 55.2 approximately homicides. Okay, and I've got a note here, a couple of things. So don't confuse mu with being a value in the data set. Okay, sometimes students do that. The value of mu will usually not be a value in the data set. Okay, usually not. It's just simply a number that summarizes all the data values. It's helpful to think of mu as like the center of gravity. In other words, mu is the value that will perfectly balance all the data values in a set. Okay, so if you're going to put all the 12 numbers on a scale, 55.2 would be the one that would balance all 12. Okay. But none of the values are 55.2. Okay, so that's all they're saying there. To find the median, we need to organize the values from smallest to largest. Okay, so the smallest number is 35, and then 38, and then 40, and then 48. Okay, etc. Because there's 12 numbers listed, I need to average the middle two. Okay, so that is the 6th and the 7th numbers. 1, 2, 3, 4, 5, 6, 7. So 54 and 55. When I add those together and divide by 2, I get 54.5 homicides. Okay, and that would be the median of the data set. Find the mode. There is no mode. So there is no value that repeated at all. And this this data set would have no mode in it. So the only time you have a mode is when there's repetition going on. Okay. Part B, suppose the number of homicides reported in September, which is 59, was incorrectly written as 99. How would this mistake affect the mean? How would it affect the median? Okay, well, mu would increase. The mean would increase. It would actually be 58.5 if you did the computation there. Why would that happen? Well, if instead of typing in 59, you're typing in 99. That's 40 more, and then you divide by 12. So it's you should probably guess that the mean the mean is going to be more than 55.2. Okay, but the median is not affected, right? Because this value here is going to be at the end of the scale now if I arrange these from smallest to largest, but I would still get the same two middle values. Okay, so the median would be the same, 54.5. Problem 4, a list of some of the best-selling video games for the U.S. in 2017 is given below. The best-selling platform for each video game is also listed, and determine the mode platform. Okay, so the mode is just the number that I see the most, or it's not necessarily a number, right? Looks like PS4 is going to be the platform that I see the most. Okay, so PS4 would be the mode platform. Okay, and this is just an example to say that the mode of a data set doesn't have to be quantitative data, although it typically is. Okay, it doesn't have to be if you're just scanning through and picking out which value you see more than any other. You don't have to have numbers. On the next page, frequency distributions can assume many shapes. 3 most important shapes are symmetric, skewed to the left, and skewed to the right. In fact, the arithmetic mean and median can be useful in determining the shape of the distribution. In a symmetric distribution, the mean and median will be close in value, if not the same. If the mean is substantially larger than the median, the distribution will be skewed to the right. And if the mean is substantially smaller than the median, the distribution is skewed to the left. Okay, so let's take a look at this here. In problem 5, the following data represent the profit, which is in dollars, of a new car dealer for a random sample of 40 cars, 40 sales. Okay, so in part A, I need to use the calculator to compute the sample mean and median. Okay, and we'll give each value to the nearest cent. By the way, we're working with money, right? So there shouldn't be any question about rounding. So you go nearest cent. So okay, in the TI-84, if I turn this on and then hit stat and then enter, okay, that brings me to some lists. And by the way, we're gonna use this function a lot coming up here. But I've already entered in the 40 sales here. So there's 781, 501, 1342, okay, etc. And so I'm ready to compute, okay. If I hit stat, go over to calc, and then I want one var stats because I've only got one variable. We'll do things with number 2 and number 4 in this menu here. But one var stats, and then I typically have to hit enter again. Okay, the mean is 1392.83. Okay, and that's a rounded value, rounded nearest cent. And by the way, your calculator doesn't know if it's a population or a sample. Okay, so they're always going to give you this, what will be the sample mean, the mean is the mean, whether it's a population or a sample, right? So it's not like it's a different formula or anything like that. If I scroll down, the median is also listed, so $1,177.50. Okay. Now those would be the values that I'm getting. Okay, and they want us to determine the shape of the distribution. Okay, so I would basically use the information that I wrote up here. So if the mean is substantially larger than the median, that's what I see. So $1,392.83 is larger than $1,177.50, right? Then the distribution would be skewed to the right. Okay, so now what we're doing here is we're saving time because in order to know that the distribution is skewed to the right, I could create a histogram and observe that, right? But there is no histogram created, right? So this is actually one way that I could still get the same result without creating a histogram, okay? The homework in this section 13.1 is on page 119. Be sure to look at those problems when you get a chance, and we'll pick up with section 3.2 then in the next video. Okay?